Okay, pause and write this down. Okay, let's start with something familiar. F of x equals x squared. Okay, familiar from Sec 5 and NYA. We call this a function. Okay, so the word function and the word transformation basically mean the same thing. So if you don't like the word transformation, you can put in the word function if you like. Okay, so familiar function, f of x equals x squared. Okay, we're going to introduce some notation. We're going to say f goes from the reals to the reals. There's that notation. You may have seen that in NYA. Okay, we're describing f in that it takes a real number x and it spits out a real number x squared. Sometimes we'll write that x is the input and then the output is x squared. So we use this differently shaped arrow here. So f takes an x and outputs x squared. Okay, so we're going to use some of this notation to talk about linear transformations. So what should I do? I'll just hit you with the definition now. A transformation. A transformation from Rn to Rm is a rule that assigns to each is a rule, let's call it, is a rule, we'll say T, we'll use T, the letter T, for transformation, just like we had F for function. Is a rule T that assigns to each x vector in Rn a T of x in Rm. Okay, so this is just like, where we had above, we had x, without the arrow, and here's your output. So again, we have the input, the vector x, and the output is we're going to call T of x. Okay, just like we have, f of x up here. So we're basically talking about a function again, right? It's a machine into which you plug a vector and it spits out another vector. So T is linear. So it's a linear transformation if for all x, y in Rn we have 1 T of x plus y. If we have this distribution, okay, when I take T applied to a sum, you get distribution. And You also require 2. T, when you have a scalar times a vector. Can't draw x as c times vector x. Okay, I also require that you can move that c out front. Okay, so a transformation is almost anything, it just has to be some rule that assigns to each x a t of x. Okay, but we can also talk about a linear transformation with the conditions given here, 1 and 2. Okay, 1 is like a distribution. Okay, you have t kind of distributing across the x and y. And here you can kind of factor out scalar multiples.